Suyuk is to join.
Yeah. Sir, if you don't mind, this SRR, I still did not get what exactly it does.
Okay.
SRR.
Actually, it is used to, it is the functionality of SRR is similar to functionality of RTR. Actually, it is,
Okay.
when it is a 11-bit identifier, we will set this bit to 1. That is, we will set the RTR bit to 1 and will encode the identifier in this place. And the
Okay.
receiver will transmit. When we see the remote frame, you will be very much, you will be clear in that topic. You as of now, you
Okay.
assume that when in a standard 11-bit identifier communication, RTR
Mm-hmm.
RTR bit will be used to will be
Okay.
made to 1 to request the other node to retransmit the CAN packet. When it comes as extended communication, these two bits are
Mm-hmm.
used, SRR and RTR. These two bits are
Oh,
used as an handshake to request other module, the transmitting module, to retransmit the packet in case of 29-bit identifier communication.
okay.
Uh,
Okay.
it is similar to remote transmission request bit. That's all. There is nothing. Don't think that SRR is something different. As the packet identifier becomes 29 bits, we need that.
Okay. Okay.
Okay.
Okay. Yeah.
Let us come back to this DLC. The DLC, yeah, they will mark these DLC number, the number of valid bytes in the DLC in a packet. Because of that, the receiver will understand that only these three bytes are valid. Remaining needs to be ignored. Okay, that, that when you see the packet, that is the field structure, it has 4 bits. Why it is having 4 bits? Why it is not having 3 bits or something like that? The can transmit maximum of 8 bytes. So you will, your DLC can vary from 0 to 8. To represent 8, you need 4 bits. As we have 4 field, you should not you should not come to a mind like, okay, it is 4 bits. The maximum, if I make 4 bits equivalent to 1, I will get F, so that I can transmit up to 15. Don't think like that, because to represent 8 itself, we need 4 bits. That's why the maximum is 8 only. So to represent 8, we need 4 bits. That's why they have 4 bits reserved for DLC. Do you understand that point? Okay, the DLC, they have given 4 bits, right? You should not think that as we have 4 bits, if I put
Mm-hmm.
1 to all these 4, I will get 15. That means F. If I put 1 to
Yes.
4,
Yes.
it is F.
Yes.
F
Yes.
means 15. So you should not assume the DLC has the ability, it has giving us permission to mark 15 so that we should be able to transmit 15 bytes in a packet. No, that is not possible. To represent 8 itself, we need 4 bits. That's why they reserved, they give 4 bits here, that we have to understand.
Okay. Okay.
Then the data fields. The data fields will have valid 8 bytes of data. So here you will encode your bytes, the valid information, which is related to the vehicle, or which is related to the other the communication. For that you are using aerospace or something like that, robotics. Then you will transmit that one to the other one. Then we have a CRC mechanism. The CRC mechanism contains 16-bit CRC sequence. It has a 16 bits are reserved for CRC sequence and CRC delimiter. What is delimiter? In C programming, when we write C programs, we used to terminate each statement with something called as sentence terminator, colon, right? That colon, it acts as a separator between two programming statements. Okay, If there is no colon, it will assume it as a single statement and will throw out the errors. That's why we use the terminal. Similar way, the CRC field needs to be separated from other fields in the packet. For that, they use the CRC delimiter. CRC sequence is nothing but a calculation done using certain polynomial the things to while they are transmitting the CAN packet, they does that one and encode it. It is not in our hand, it is done by the module itself. We no need to bother about it. The CRC sequence will be the 16-bit sequence, and then we used to have a delimiter. The delimiter is something similar to terminator, sentence terminator in C. It has single recursive bit. The CRC delimiter is a single recursive bit, 1 bit for a termination of CRC field. Then we have acknowledgement field. The acknowledgement field has 2 bits. One bit is for 1 bit is used for acknowledgement, and another bit is acknowledgement delimiter. It's nothing but a separator from other fields. Okay, this acknowledgement bit, right? Whenever a node transmits a message, it will make that acknowledgement bit as 1. That means this needs to be acknowledged by somebody in the bus. It will transmit the packet. The packet is now in the bus. When it is acknowledged by the receiver makes the acknowledgement bit to 0. That means he will make it to dominant, so that that transmitter will understand that my packet is acknowledged or received by other node, something like that. So for that they use the acknowledgement bit. Let me repeat. The acknowledgement bit will be made to 1 by the transmitter while transmitting. Then the receiver receives it successfully. It changed the acknowledgement bit from 1 to 0. That's all. The remote frames. We have a remote frames here. The remote frames, the difference between the remote frames and the data frame is you won't have data fields in the remote frame. That's it. Nothing more than that. Nothing. Other things are other things are similar, same as that of data frame. Arbitration start of frame, arbitration field, control field, CRC field, acknowledgement field, end of frame, everything is same. Only thing is we don't have data fields. Reason why we don't have data fields, actually the remote frames are used to request other module to retransmit a message. So there is no requirement to have some data bytes to be communicated to the transmitter, only other than the identifier of the packet. So we will have in arbitration field and control field will have the identifier, and then the remote frame will have its data field empty and will be transmitted to the bus. The other node will understand, will by seeing this, it will understand it as a remote frame. How it will understand? There is to be an RTR bit, right? That RTR bit will be set to 1 for remote frame. If it is 1, upon when the frame is received, the receiver will check the RTR bit. If it is 1, it will assume that it is remote frame. Then it will retransmit the frame which has the identifier that is encoded in the remote, something like that. Then we have, do you understand right now what is remote frame? Remote frame is transmitted by the receiver to the transmitter to retransmit a frame when the frame is corrupted in the bus. How that is how it will communicate to the transmitter. It will encode that identifier to be retransmitted in the frame and then will send. So transmitter will understand that okay, this is the remote frame by the RTR bit, and then it will decode the identifier from the arbitration field, and then it will send that packet again as a data packet to the receiver. This will happen until the receiver receives valid data packet. It didn't receive it, it keeps on sending the remote. Send it again, send it again, send it again. Like that, it will keep phone request the transmitter until the successful reception happens. Then we have error frames. We have error frame consists of two fields. Similar way, error flag and error delimiter. The error delimiter is nothing but a terminator or separator of error field from other fields. The error flags. These error flags, actually, we have two types of flags, error flags. One is active error flags and then passive error flags. This active error flags, right, it has a 6 consecutive dominant bit, and the passive error flag will have 6 consecutive recursive bits. Okay, so up to 127, your error will be, whenever there is an error, it will be counted by module. It will count, the can module will count the error. Okay, one error happened, two error happened, three error happened. Like that, when it reaches the 127, till that time it will see that as an active error. That means the error that can be solved, something like that. When that limit is crossed, 127 is crossed, then it will say it is a passive error. So it is something like it cannot, it looks like this error cannot be solved very quickly. It may take some time, something like that. When it crosses, it counts, after that also it counts the error. When the count crosses 255, that is a very big 255. When the 255 error count happens, okay, it will wash its hand. Okay, now this is the time I have to go for bus stop, because using this guide there is no use. Keeping this node in the bus will not produce any value to, it will not add any value to the bus. Let him to go for bus sleep, I think bus off. So they will move that mode to bus off. So the node will not stop all the transmission and will go to bus off stage. It is a predefined wait time in idle state. After that predefined time is over, it will come up again and will retransmit the message. That's how that error detection and correction mechanism works in the can. Assume your that some three error code happens. In that time, the error is resolved. Error is solved. If that is the case, the node will not be blocked. It will be allowed. It is allowed to retransmit without any problem. It is come to the normal. So it encountered the problem for a short period of time, and then it recovered. So it is working fine now. So they will allow it to transmit the thing. But the problem, the termination will happen only after 255. That is counts. Overload frames. This frame is assume a transmitter is transmitting the frames in a very high speed to the receiver. That the receiver needs some delay because the frames are not up to the enough to take it. That is, the receiver is struggling to handle the frames. In that case, it will transmit. The receiver will transmit to the transmitter. I need a delay to accept the next frame. So you wait. So it is something like that. So when the receiver is overloaded, it used to do this one. So the overload frames, how a overload frames will look like? It used to have a overload flag and overload delimiter. Delimiter is a separator that we know. What a overload flag will look like? The overload flag will be something like, it is consecutive, 6 consecutive dominant bits transmitted from receiver to transmitter. Okay, that is the thing which makes the overload frame, to that is the transmitter to understand that okay, this is overload flag. So we have to wait for some time to before transmitting the next frame. Overload delimiter consists of 8 recursive bits. This overload separator will have the 8 recursive bits. 8 ones will be used as a separator. The overload flame will not have any identifier, arbitration fields, nothing. Similar way, the error frame also will not have any identifier uh, or control fields, nothing. Just error flag, error delimiter. Overload flag, overload delimiter. That's all. Interframe spaces. So sometimes we need the intermissions between the packet transmissions. In those cases, the module itself introduce some sort of small delay um, between frames. They are called as interframe frames. Overload frames and error frames are not preceded by the interframe frames. Assume you are at the error is occurring. The error frames will not be separated by interframes because that is not required. Only when it's a valid packet is going on in those cases. Otherwise, when a remote frame request is transmitted, in those cases only the frames are separated by interframe space. Otherwise, the interframe space is not appropriate to use. That's why they are not using it. The intermission subfield consists of three recursive bits. They use three recursive bits. During intermissions, no node is allowed to start transmission data frame or remote frame. Though the bus is free, if that is an intermission time, so the no node is allowed to transmit the, the frame because it is in the interframe space. It is three recursive bits are used as a interframe space. In that time, no node is allowed to transmit anything. Period of bus idle may be of arbitrary length. So it is an arbitrary length. It will vary over a time. After the error passive, the node has transmitted a frame. It sends 8 recursive bits following the intermission. Before starting to transmit a new message or recognizing the bus as idle. So after an error passive, node has transmitted a frame. A node is transmitted error passive frame. It sends a 8 recursive bits following intermission. Okay, so it transmits 8 recursive bits following the intermission before starting the transmission. Okay, intermission after intermission, that means 3 recursive bits. They are transmitting additional 8 recursive bits before starting to transmit new message. Otherwise, recognizing the bus as idle. That's how it is. The next thing is message filtering. The node uses the filter to decide whether to work on the specific message. That I already told. The filtering is primarily done on the identifiers. So the nodes will filter the messages based on their identifiers. The message filtering is applied to the whole identifier. The node can optionally implement the mask register so that specify which bits in the identifier are examined when the filtering happens. Okay, this filtering they will examine, otherwise they will inspect the bits of identifier and will make the decision that whether we have to work on this message or not. For that, they are defining a mask for each nodes to accept or reject certain messages. Bit stream encoding. Okay, now you are almost enter into the place called physical layer. So now you are about to transmit your packet out to the physical line. So in that time they are encoding the they are bit stuffing. They are bit stuffing the frame to avoid the communication errors. As I told you before, they introduce in complementary bits when they see identical bits of same type. If they see consecutive ones, 5 ones, they will 6 ones. After 5 ones, they will introduce a 0. If they see consecutive zeros, after 5 zeros, they will introduce the one recursive bit in that. So to understand this, I have a diagram here. this represents, this is the this diagram explains the top one is without the bit stuffing, the bottom one is with bit stuffing. If you see this, here we have arbitration field. It is an identifier. So in which the startup frame is 0, and then we have 6 consecutive zeros without bit stuffing. So when you see this, the physical layer in the transmitter will see that, okay, we have 5 consecutive zeros, including startup frames. Okay, then I will introduce a complementary one here. Now, after that, there is no change, so it goes up. From the receiver side, as they introduce 1 in the bit physical link, the receiver will receive, right, this one. First it will receive the startup frame, and then it will receive these things one after another. It sees, if the receiver sees 5 consecutive zeros or 1, it will understand that the next bit is a bit stuff the bit. So we have to ignore that. It should not be considered. So that after 4 bits of the identifier, it will ignore the fifth one and will consider the other bits which follows. So that exactly what we transmitted, right, in the orbit, that is identifier, that will be received. Actually, after introduction of 1 in the arbitration field for bit stuffing, the identifier value is changed. Actually, here the identifier value is 1 4. Actually, it is 24 0, sorry, it is 14. 14 means, 14 in x means 20 in decimal. Actually, without bit stuffing, the identifier is 20, but after introduction of bit stuffing, the identifier value becomes 0001, uh, 94. Actually it becomes 94 from 20. That is wrong. Actually, um, 94 in x, actually 94 in x, 94 in x means it is very big value. But how that the receiver will understand it is only 14? Because when it sees the bits sequentially, because it is serial transmission, it will bit by bit movement. When it sees six six five consecutive zeros or ones, it will assume that sixth bit is an bit stuff bit. It will simply ignore that and will move forward. So like that, it's working. This is how they used to bit stuff the frames, which is the bits which is transmitted over the CAN. Then we have errors. Okay, so um, I want to stop here today because we have covered almost up to some 70 percentage of this CAN related stuffs. We have only errors and other stuffs. I want to take it by tomorrow. If you have any doubts, you can ask now. Up to this, whatever we see, right, in this. Do you have any doubts? Or everything is clear, or nothing is clear?
It's clear. It's clear.
Okay. I don't know why I spoke very energetically today. Because of that, my voice broken now. So I believe I cannot handle next half an hour. Um,
Yeah, please,
we
please
will
take
we
this.
will we will see. Okay, then our next session will be on Monday. Is it okay for you to attend the morning session in weekdays? Will you face some challenge or something like that? In morning 6:30 to 9.
Uh, so what about weekend, sir? Weekend it is off all the time.
I think for you, I want to take some special. Saturday, I want to give you.
Okay.
That is a special case only for you. I am doing it. but we need to cover at least 2 or 3 sessions in the weekdays. I want you to confine me when you are able to attend the morning session 6:30 to 9. It would be very great for me. Can you
Y-
find some opportunities in weekdays in these 2 days or 3 days? I can attend the morning session, something like that.
Yeah, yeah, I can.
You can do that, right? You work on it
Yes, yes.
and come back to me on Monday. You won't have a session. Tuesday only we have session, so that in Tuesday, you I need to know uh, in which days you are free. In weekdays.
Actually, from after Diwali, my manager has called me to office, so
So
I have to think about.
okay,
Mm-hmm.
okay, okay. You will move to Bangalore.
Yeah. So I don't think so. At that time, morning session I can manage, sir.
Okay.
So
Uh, it-
after
uh,
Diwali,
okay. After Diwali, the Diwali still we have some 14 days, right? If I'm not
yeah.
14 days.
Not 14, I think one more week
For
exactly.
week we have.
Mm,
Okay, within that
10
week
days.
we might have completed almost some. We ask, we will put more times in Saturday.
Yeah.
We have only one Saturday, but is it closer to Diwali next Saturday? Can you tell me? Because it
Yeah,
is
it is
14
next Saturday only.
next Saturday. Okay, then that is not
Yeah,
possible.
yeah.
Because you
Mm,
need to celebrate your function, right?
yeah.
Mm,
Yes.
okay. Okay, what we'll do, it is I am handling you as a special case. Is it possible for you to attend tomorrow, Sunday,
Y- y- Tomorrow at what time, sir? Morning only?
morning 6:30 to 9? Because I am,
Yeah,
it is not a
sure.
problem. Okay,
Tomorrow.
morning,
No
tomorrow
problem.
I will send the meeting request to you. We will cover this
Okay.
topic. We will complete. Whenever we find the times, we will use that in your case. But we need to
Sure.
stick to some morning schedule. You think and come back to me some days.
Sure.
Okay?
Yeah,
Okay, Guru.
sure.
Thanks a lot.
Yeah,
Mm,
thank you, sir. So it's tomorrow. Okay, fine.
yeah.
Next session.
Yes. Thanks. Bye.
Thank you very much. Bye, sir.